Mars AI, exploring the red planet. NASA's Mars rover uses AI to conduct scientific research on the red planet. AI is being used by NASA's Perseverance Mars rover mission to explore the red planet. For around 3 years, the rover has been experimenting with AI to explore Mars and find important rocks and minerals for study. NASA is now using AI to identify the most important rock samples and to decide on its own whether to provide real-time rock sample analysis. AI is being used by NASA's Perseverance Mars rover mission to explore the red planet. For around 3 years, the rover has been experimenting with AI to explore Mars and find important rocks and minerals for study. NASA is now using AI to identify the most important rock samples and to decide on its own whether to provide real-time rock sample analysis. The space organization's ongoing research and development is creating a smart space exploration future in which the organization's goal of more realistically interpreting Mars will be approached by smart spacecraft that can complete the mission on their own. AI and the PIXL instrument are two tools used by NASA rovers for detection and analysis. These instruments aid in identifying the most advantageous locations for drilling and sample collection. "We use PIXL's AI to home in on key science," said Abigail Allwood, JPL's principal scientist for the instrument. "Without it, you'd see a hint of something interesting in the data and then need to rescan the rock to study it more," he said. This enables PIXL to finish without human data analysis. The spectrometer, termed PIXL, is mounted atop the 6 tiny robotic legs or hexapod that make up Perseverance's robotic arm. Legs aid in positioning and provide precise control and stability. To ensure precise alignment, the PIXL equipment has a camera that continuously measures the separation between it and a rock target. This displays the historical circumstances of the Martian terrain, a function of this equipment called adaptive sampling. Perseverance is not the only use of AI on Mars. NASA's Curiosity rover, located some 2,300 miles distant, has developed a new kind of artificial intelligence that allows it to use a laser to select rocks on its own based on their color and shape. After that, it looks at the target's PIXL scans to identify the minerals that need further research. Remarkably, all of this takes place in real time, saving the rover from having to communicate with mission supervisors on Earth. The greater autonomy allows the rover to make rapid decisions and immediately gather critical data, greatly increasing the efficiency and effectiveness of its scientific research. Here's how AI is changing NASA's Mars rover science. Scientists are using artificial intelligence to assist them find minerals in rocks that the Perseverance rover is studying. With smart spacecraft that know precisely what data to seek for, where to find it, and how to evaluate it, some scientists envision exploring planets. While it will take decades to turn that ambition into a reality, developments with NASA's Perseverance Mars rover provide encouraging first steps. The rover project has been testing a kind of artificial intelligence that looks for minerals in the rocks of the red planet for over 3 years. This is the first instance of AI being used on Mars to make judgments on its own using real-time rock composition analysis. AI is being used on Mars for purposes other than adaptive sampling. NASA's Curiosity, which is located around 2,300 miles, 3,700 kilometers away from Perseverance, invented a kind of artificial intelligence that enables the rover to use a laser to strike rocks on its own depending on their color and shape. Chemical makeup of a rock may be determined by examining the gas that burns off after each laser zap. This similar capacity is present in Perseverance, along with a more sophisticated AI that allows it to traverse without earthly guidance. Though these digital smarts help both missions do more in less time, the rovers still depend on teams of engineers and scientists to design each day's hundreds of individual orders. According to Peter Lawson, who oversaw the adoption of adaptive sampling at JPL prior to his retirement, the idea behind PIXL's adaptive sampling is to help scientists find the needle within a haystack of data, freeing up time and energy for them to focus on other things. In the end, it speeds up the collection of the best science. Using AI to position PIXL. PIXL benefits from AI in 2 ways. When the instrument is close to a rock target, it first precisely aligns the instrument. Perseverance's spectrometer is situated at the end of its robotic arm and is supported by a hexapod, which is a set of 6 small robotic legs. To help with placement, PIXL's camera continuously measures the separation between the instrument and a rock target. Perseverance's arm may expand or shrink a tiny amount because to the wide temperature variations on Mars, which might interfere with PIXL's aim. The device is automatically adjusted by the hexapod to reach very near without touching the rock. To get the accuracy we need, we have to make adjustments on the micrometer scale, Allwood said. It approaches the rock closely enough to make an engineer's neck stand up. Making a mineral map. Another AI system has the opportunity to flourish once PIXL is in place. In order to produce a grid of tiny dots, PIXL fires an X-ray beam millions of times over a postage stamp-sized section of rock. Chemical makeup of the minerals present is revealed by each dot. Answers to important issues regarding Mars depend on minerals. Depending on the kind of rock, researchers may be searching for phosphates, which, if present in the Martian past, may have served as nourishment for microorganisms, or carbonates, which conceal hints about how water may have produced the rock. Although scientists cannot predict in advance which of the hundreds of X-ray zaps will reveal a certain mineral, the device may automatically pause to collect more data when it detects a particular mineral. This process is known as a long dwell. The list of minerals that PIXL can concentrate on for an extended period of time keeps expanding as the system becomes better via machine learning. David Thompson of JPL, who contributed to the software's development, described PIXL as a type of Swiss Army knife that may be set up based on the scientists' current needs. Mars is a great place to test out AI because we have daily communications, which allows us to make adjustments as we go. NASA's Moon to Mars exploration strategy, which includes Artemis trips to the Moon to help get ready for human exploration of the Red Planet, includes the Mars 2020 Perseverance mission.